the Poisson distribution calculating probabilities by modifying lambda. The number of vehicles passing per minute at 4 AM on the northbound M1 carriageway at Luton can be modelled by a Poisson distribution with mean 15. Let's represent this information in a table. The value of lambda is 15, and we're looking at a 1 minute interval. So time-wise we can say 1 minute or 60 seconds. So if a question was to say work out the probability of something happening in a 30-second interval, then you would think, okay, that's 60, that's 30 seconds. So if you're going to multiply this side by a half, you do the same on this side. So the value of lambda you would work with is 7.5. Or let's say we're looking for a 6-second interval. 6 seconds. So to get from 60 to 6, you're dividing by 10. So you divide the 15 by 10. So the value of lambda is 1.5. Or if we're looking at a 2-minute interval, you're multiplying by 2, you multiply lambda by 2. So the new value of lambda is 30. Once you've modified your value of lambda, you carry out doing the calculations as before using the cumulative tables. So what's the probability that fewer than 5 vehicles, so that's the probability that x is less than or equal to 5, fewer than 5 vehicles will pass in a 30-second interval. So lambda is 7.5, so we know we have the Poisson distribution with a mean rate of 7.5. You go to the tables, lambda is 7.5. We're looking for less than or equal to 5 here. There's the probability, 0.2414. In this example, we look at a number of Poisson distributions. So this is a Poisson distribution representing the discrete random variable A that has a value of lambda equal to 1. We have a discrete random variable B that has a lambda value of 2, and we have a discrete random variable C that has a lambda value of 3. Now A, B and C, A, B and C are independent Poisson distributions. If A, B and C are independent, then what you can do is add the values of lambda together. The Poisson distributions A, B and C could represent the number of people queued to be served at 3 restaurants in 3 separate towns, all owned by the same person. Because they are in different towns, they are completely independent of each other. So the total number of customers who are queued would have a lambda value of 1 plus 2 plus 3. So we now have a Poisson distribution with a mean value of 6. So then the question might say, what's the probability that the total number of customers who are queued at all 3 restaurants, so if you combine all 3 restaurants together, or takeaways together, the total number of customers queued is at most 5. So the lambda value is 6, and we're looking for less than or equal to 5. Lambda is 6, less than or equal to 5, 0.4457. 0.4457. Now the only reason that you can add these values of lambda together is because A, B and C, these Poisson distributions, are independent of each other.